Hi guys, welcome back. So we've talked about probability in this chapter, and today we're going to talk about probability models. So how do we show the probability? So in the warm-up, go ahead and take a second. What's the difference between experimental probability and theoretical probability? So pause the video and come back and see if you have the same answer as me or a similar answer. So remember, experimental probability is when we actually perform some sort of experiment. Okay, we toss a coin, or we practice pulling marbles out of a bag, or we spin the spinner, right? So experimental is some sort of experiment, right? You actually try it. Okay, and theoretical probability is what's going to happen in theory. Okay, so when we roll a die, we should get the number 1 out of 6 times. We should get the number 2 out of 6 times. If we have equal parts on a spinner, so if we have 4 parts, there's a 1 in 4 chance of getting the red, 1 in 4 chance of getting the yellow. Okay. Sometimes we also call experimental the relative frequency. Okay, I'm sorry, I can't write very well today apparently. Okay, so relative frequency is another word for experimental probability. So we've been finding all these different probabilities, and we can show them off in a probability model. So a probability model shows the sample space of outcomes, events, and the probability of those outcomes and events. So the first model we're going to learn about is a uniform probability. So if we think about the word uniform, what comes to mind for us? And hopefully for most of you is you wear a uniform to school. And uniform usually means you have to wear the same thing, right? Now, thankfully at SHA you have lots of choices in what you wear, but when you were in elementary school, you had fewer choices, so you all looked very similar, okay? Whereas in the high school, you looked a little different. But uniform means the same, right? You all have to wear a polo, you all have to wear khakis. That's what uniform is for us, okay? So uniform probability means that all of the outcomes have an equal probability of occurring. So in theoretical probability, this would be like flipping a coin or rolling a dice, or a die for the proper singular there, okay? So we're going to graph a probability distribution, okay? So we have these random counters, okay? We have a yellow one, a red one, a blue one, a green one, and a black one. So first we wanted to find the sample space, which we did earlier in this chapter. So I'm going to do S, because it's sample space, and that's all of my possible outcomes. So I'm going to have yellow, and red, and blue, and green, and black, right? Those are the only outcomes, oops, sorry guys. The only outcomes I can possibly have. Those are just the 5 different colors that we have. Okay? And if I'm looking at this, if I were to put these all in a bag, what's the probability of each one occurring? Well, the probability of getting yellow would be 1 out of 5. Probability of getting red would be 1 out of 5. Probability of blue, green, and black would all be 1 out of 5. Okay? Because I have equal chance of picking them. One's not bigger than the other. There's not multiple blue ones. There's not multiple red ones. There's 1 of each out of the total 5, and they're all the same size. Okay? So what we're going to do is on the next page, there's a little chart to fill this information in. So go ahead and pause the video here and fill it in so that way you are with me when we move on. So all I did was put the color here and say, okay, yellow has a 1/5 chance, blue has a 1 in 5 chance because it's the colors versus the probability. Okay? And now we're going to draw a graph, or a bar probability model to show this. So on the bottom, which when you have a chart like this, that's going to be your top one, is my color, right? So I'm just going to shorten this to yellow, blue, green, red, and we'll call this BLU. This will be BLA. Okay. Now, uniform probability, I have 1/5, and we'll do 2/5 just so we can see here. Okay. So the yellow, so here's my graph, so if you need to pause the video here, go ahead and pause it and catch up with where I am. So yellow has a 1 in 5 chance of occurring. Blue has a 1 in 5 chance of occurring. Green has a 1 in 5 chance of occurring. So each of my bars are all going to go up to 1/5. Again, because it's uniform probability, so all my bars are going to be exactly the same height. Okay? There's not going to be one like way up here. Okay? Uniform, all the same. So across the board, we should look the same. So across these probabilities here, it should all look the same. Okay, again, uniform. So we have Liz, Taylor, Brock, Gabe, Laura, Natalie, and Delaney, our students. A teacher, maybe me, randomly chooses one of them to answer a question. Okay? Excuse me. So it says explain why a uniform distribution describes a situation. So why would this situation be uniform? And that's because each student has the same chance of being picked. So like in my class, when we're in our actual classroom setting here, I have my cup of sticks, right, where I call you all randomly, right? You all have the same chance of being picked. I'm not sitting there looking, oh, who can I pick on today, right? Sometimes we do that in class where it's just whoever raises their hands, but for the most part, we try and pick sticks, right? So that is saying we all have an even chance of being picked, or we all have the same chance of being picked, okay? So what's the probability that Gabe is randomly chosen to answer this question? So there's one of Gabe. There's not two Gabes in the class. And we have 1, 2, 3, 4, 5, 6, 7 total students to choose from. So there's a 1 in 7 chance that Gabe is going to be chosen. And just to kind of review some things, what's the probability of choosing a girl? And we're calling that event A. So the probability of A, we know there's a total of 7 people, so we're going to call it 7. So if I look at my girls here in my class, we have Liz, we have Taylor. Taylor is a girl in this class. Brock, Gabe, Laura, Natalie, and Delaney. So there is a 5 out of 7 chance that we will pick a girl. And if you're curious, this is the current sophomore class with the class of mostly girls. That's why they have a higher probability of getting a girl than a boy. Okay? So your exit slip, I'll read it to you and then have you pause and come back. A number is chosen at random from a list. So we have a list of 1, 4, 7, 12, 21, 25, 38, 40, 45, and 48. Explain why a uniform distribution model describes a situation. So we have no repeating numbers, right? Again, each number has the same chance of being picked, just like what we had in part A for our previous problem, right? So good luck. Try